My dear students, welcome to session 9, module 2, fluid mechanics. Today we will try to solve some problems on the hydrostatic force and center of pressure. Before I commence my lecture, I would like to tell you this module 2 has got hydrostatic forces on surfaces, and in the 2B we have fundamentals of fluid flow, which we call kinematics. The learning outcome, the student will learn to determine hydrostatic force on submerged plane and curved surface and its application to gravity dam and log gates. The other outcome is the principles of kinematics and hydrodynamics for practical applications. So with this objective in mind, we would like to take the first part, which is hydrostatic forces on surfaces. Before I begin the problems today, I would like to tell you very clearly, today we are going to use the standard formulae for centroid location, moment of inertia. For example, I will show on the board. You can see for a rectangle of B by D, rectangle, the area is BD. Along the x axis, the moment of inertia is BD cube by 12. Again, along the x axis, moment of inertia is BD cube by 12. Centroid, no doubt, at B by 2 and D by 2. Is it okay? So as far as the rectangle is concerned, we know the inertia value is BD cube by 12. Let us take one more, a triangle of base B and half height H. Triangle, the area is half base into height, that you know. The moment of inertia parallel to x axis passing through centroid, the moment of inertia parallel to x axis passing through centroid is BH cube by 36. B is the base, H is the height of the triangle. The centroid is B by 2 and H by 3. Let us take the circular. Suppose if I talk about the circular plate of radius r, the area is pi r square. The moment of inertia parallel to x axis pi r4 by 4. Centroid is at the center, that is why I have given 0 0. Is it okay? Circular area pi r square, moment of inertia pi r4 by 4, both sides x and y also, and centroid is at the center of the circle. Is it okay? Suppose if I take a semicircle, half of the circle, in that case the area will be half of this, which is pi r square by 2. The moment of inertia passing parallel to x axis is 0.11 pi r4, and centroid will be here, the value will be 0 and 4r by 3 pi in y direction. Okay, 4r by 3 pi. So these are the standard formulae we are going to use when we compute the hydrostatic force and also the location of center of pressure. I repeat, we are going to use to calculate this centroid and moment of inertia for hydrostatic force and center of pressure for a plane figure. Is it okay? Now let us come back to slides. Same thing is repeated. I will go ahead. Now today's discussion, mind it well, we would like to take a plane surface, maybe a plane surface maybe of this type. It could be kept horizontal, it could be kept inclined with theta degree, and it could be vertical with theta is equal to 90 degree. Is it okay? So we would like to know how to calculate the force when it is horizontal, how to calculate the force when it is inclined, and how to calculate the force when it is vertical. The formula is there in front of you. My dear students, make a note that the force is given by F or P is equal to intensity of pressure into area of the plate. For example, if this is the plate, intensity of pressure at this point into area of this particular rectangle. Is it okay? So that is nothing but specific weight gamma f into h centroid. H centroid is the value, the centroid of the area from the free surface. Okay, I will show you a small demonstration to you. You can see it is a small plate of a rectangular shape, correct, of a rectangular shape. So, when I talk about if I immerse this particular shape in water, I will use the formula gamma w, which is nothing but 9810, which has come from density into G. Density is 1000, which is there on the slide, into G 9.81, and HC. This is the water level. You can see the water level is here and the centroid is here. So, this distance your HC, this distance is your HC, is it okay? So, in that case, definitely if it this depth is D, this value will be D by 2, correct. If this depth is 10 centimeter, this will be 5 centimeter. So, I will be able to calculate the force on this particular rectangular plate when it is in this direction, is it okay? Now, let us see the formula which we normally use. As I mentioned to you, we are going to use today a plate immersed horizontally, inclined with a theta, and vertical theta as 90 degree. The formula for this, the center of pressure formula is HCP is equal to HCP, you can see the cursor, HCP is equal to HC plus Ig sin square theta by AH bar. Ig is the moment of inertia about the depth axis, this way. For example, if this is the way, I will take along this axis. Okay. Now, in case if it is horizontal, my dear students, we are going to apply the formula, same formula for center of pressure. Theta is equal to 0 degree. So, sin theta will become 0 because sin 0 is 0. So, this whole term becomes 0. So, HCP is equal to H bar. So, as long as the plate is rectangle and if it is in the horizontal position, we can say HCP and HC, they will coincide at the same point. Is it okay? Now, let us come to the next one. When it is having an angle of theta, we can use the formula as it is. You can see it will be slightly below the centroid. You can see the cursor centroid CE and CP, which is slightly below, as I have also shown in this diagram also. It is the centroid C and this is center of pressure, which is slightly below. This could be, for example, this is 10 centimeter, this could be hardly some 5 mm or 3 mm depending upon the depth where it is located. Okay. So, we are going to use this formula for plate which are inclined. HCP is equal to H bar plus Ig sin square theta into area of the plate, which is this B into D into H bar. So, is it okay? Now, let us take the third case, which is called vertical case. It means same plate, horizontal theta equal to 0. Now, theta is inclined, I make it vertical. I make it vertical. It means like this for to show you. So, theta is now 90 degree. In the same formula, the center of pressure from the water level, I repeat, center of pressure from the water level will be at a distance of H bar. You can see in the formula H bar plus Ig sin square theta by AH bar. What is theta now? Sin 90. Sin 90 is 1. So, sin square theta is 1. So, H bar plus Ig by AH bar may be slightly below this. So, we have 3 cases in which we are going to work like this one by one. Is it okay? Are you ready with the formula? Right. Let us talk about the curved portion also before we start the problems on the plane surfaces. As I explained to you yesterday, any curved surface, let us take this glass. This is a curved surface, and assuming that there is a water on this side, say this side, correct? So, how to calculate? Yesterday, as I told you, the curved surface will be having 2 components. One is the horizontal and other is the vertical. Repeat, the curved surface will be having 2 components. One is the horizontal force, hydrostatic force, and other one is the vertical force. Then you may be thinking, okay sir, we understood it has got 2 components. The curved surface has got 2 components. How to calculate? the answer is so simple. As far as the hydrostatic force on the horizontal direction is concerned, we are going to project it on a plane surface. It means this particular tumbler will become a rectangle for me of this much height and whatever width is given in the question. So that becomes a rectangle and it will be acting at exactly half of the distance. So gamma W, which is nothing but 9810 into area of the plate, I will take this projection. Area, this will be the length and this will be the depth, correct, as a rectangle, projected surface as a rectangle, right. It will be into A into the HC bar, which is whatever depth is there, d by 2 we will take. So that is the way we calculate the horizontal component. So you have understood very clearly that if the face is horizontal or a curved one, we are going to take a projection like this equal to the width of this one. So rectangle, area is L into D, and the force will be as per the hydrostatic gamma W, area of this rectangular projection into HC bar. HC bar is the centroid of this rectangle, which is nothing but depth by 2. So from the top we will take d by 2, that will be the answer. Okay, so you have understood that as far as the curved surface is concerned, we are going to get two components. One component is along the horizontal direction and other component which I am going to talk now is the vertical. You can see the vertical component of force on a curved surface equals the weight of the pressure prism necessary to cause the pressure on the surface. So simple, you can see here, this is the curved portion of the gate and I have put a line B to C here and C to D here, and again it is joined B. I have hatched it. You can see the hatching. Can you see here? Same thing you can see here also. B, it's a 3-dimensional view. B, C, D, A and B. So whatever the weight is there, that weight is nothing but the vertical component. The moment I say weight, it is going to be volume into gamma W. Volume of that particular face into gamma W. What is gamma W? The specific weight of the liquid. What is the specific weight of the liquid? Density of the liquid into G. This formula we are practicing for a long. Gamma W is equal to rho into G. Now what is the area of this particular thing? You can see, if you see this diagram, you can see it can be split into two parts. One is the quarter of a circle and one is the rectangle. Can you calculate the area? Quarter of the circle will be pi r square by 4, correct. Quarter of the circle will be pi r square by 4. I told you, semicircle pi r square by 2, circle pi r square, 1/4 of the circle pi r square by 4. Is it okay? Now that area we can estimate and we can calculate this rectangle. Now you may be thinking, okay sir, we got only the area, not the volume. My dear students, gamma W, which is 9810 for water, into area, I will take area of a quarter circle plus you can see the area of a rectangle. Can you see the here? Rectangle will be from here to here. So this width into this depth I will calculate, and you may be thinking what will be the length? Length will be the length of the gate. You can see my hand. It is exactly, if this is the portion, this particular width which I am showing you here to here, that is your length. You can see here also, this is going to be the length of the gate. So that way we are going to multiply these two respective area with the same length to get the volume of the water which is above the curved surface. Now again I will read the statement. The vertical component of force on a curved surface equals the weight of the pressure prism. Indirectly you can say volume of the pressure prism, because you are multiplying by gamma W, correct. That volume is nothing but this particular rectangular area plus this pi r square by 4 or a small circular area, correct. This multiplied by perpendicular to this is the length which is shown in this 3D, say this is the L, say 1 equal to 1 meter. So we can calculate the total vertical component per unit length of the gate also, or we can multiply with 2 meter, 3 meter, 6 meter depending upon the length of the gate. Is it okay? So with this I think I have almost covered the basics required for today's journey. We will start the first problem. We will read the statement. I hope my students are ready with their calculator. We are going to solve one by one problem. See, your confidence increases to calculate the hydrostatic pressure force as well as the position of center of pressure. Okay? Let us read the first question. A rectangular plate 4 meter long and 1 meter wide is immersed vertically in water in such a way that its 4 meter side is parallel to the water surface and is 1.5 meter below it. I read the question again. A rectangular plate 4 meter long and 1 meter wide is immersed vertically in water in such a way that the 4 meter side is parallel to the water surface and 1.5 meter below it. Find number 1, total pressure on the plate. Number 2, the position of center of pressure. So definitely is asking you the F and the center of pressure. Okay, but before we start, let me show you how it looks. You can see it's a rectangular plate of 4 meter long. You can take this as 4 meter long, okay, and this depth you can see as 1 meter, and it is immersed vertically. It means you are in front of a water tank. In the water tank you are seeing this plate exactly like this as 4 meter here and 1 meter depth. Now he is saying you that the water surface and is 1.5 meter below. It means water surface is somewhere here. What is this gap from this point to this point? It's 1.5 meter. Is it okay? This is not the water level. Water level is here and it is depth at 1.5 meter. Okay. So now we would like to know what is the force going to act on this system. Let's go one by one. Given the gamma W, the specific weight of water as 1000 into 9.81 as shown in the slide. Area of the rectangular plate, I think you are enough smart to calculate length into depth. What is the length? 4 meter. And what is the depth? It's 1 meter. So the area of the plate is 4 meter square. The centroid is at a distance of, let me calculate. This value between this plate and this water level is 1.5 meter. So definitely in the formula I am going to add 1.5 meter here plus d by 2. What is your d by 2? Depth is 1 meter. See, this is 4 meter long. This is 1 meter. So half of this. So we can see in the formula it is 1.5 meter, which is from the water level to this point 1.5 plus half of this. So HC in the slide you can see HC is equal to 1.5 plus 1 by 2, that is going to be your 2 meter. Okay. Now how to calculate the hydrostatic force? To calculate the hydrostatic force we can see the formula gamma W, which is 9810 into the area which is 4 and HC, which is the location of the centroid from the top 1.5 plus 0.5, which is 2 meter, that you can see in the formula, and it is being multiplied and the answer is 78480 newtons. Okay. I have mentioned one more thing in the slide. You can see, note the word vertically immersed. Vertically immersed means I am looking the plate exactly like this in front. It is not like this. It is like this. Okay. Is it okay? Now let us see the further. I think the same diagram is coming here also. The centroid is here. This value is 0.5, right? And this value we would like to calculate. What is the formula? The center of pressure formula is HC plus ICXX into AHC. The moment of inertia along the x-axis you can see BD cube by 12. It will be BD cube by 12. What is the B? 4 meter into what is the depth? It is going to cut along the x-axis. You can see in the diagram here also along the x-axis. So this is your 4 meter and this is your 1 meter. So B into D cube by 12, it means 4 into 1 cube by 12. So please calculate with your calculator for a plate which is lying at a 1.5 meter below the water level, and we would like to calculate the center of pressure. I know the magnitude we already calculated. So I would like to know where this is acting. So in the formula, HCP is equal to HC, which is 2 meter. Moment of inertia, the value you can work out, 0.333 meter to the power 4 divided by the area of the plate. I need not tell, 4 into 1 meter, which is there in the diagram also, 4 into 1 meter, the answer is 4 here, and HC is again 2. So if you calculate, you can see if the centroid is at 2 meter, the center of pressure is 2.042. Can you imagine? It's very near. So mind it well, the center of pressure for this small problem in which the plate was lying 1.5 meter below the water level for a rectangular plate having 4 meter length parallel to water level and depth is 1 meter. We have calculated based on the formula HCP is equal to HC plus ICXX divided by AHC. Centroid depth from the free surface 1.5 plus this is 0.5 because this is 1 by 2 is 0.5. So we have 2 meter. The moment of inertia of a rectangle BD cube by 12 parallel to this passing to centroid. B is 4, which is 4 here. D cube is 1 meter cube divided by 12. Substitute the value of the area of the plate, 4 into 1, and we get the center of pressure. So this is the way we have solved a simple problem of a rectangular plate immersed in water at a distance of 1.5. Hopefully you have followed this first question, which is, you can say, it's a benchmark problem, correct? Let's see next problem. Now in the next problem, what I did, I am taking the same plate. You may be surprised why sir is taking same plate. See what I did, I have immersed vertically, now I will do it horizontally. Understood? Earlier I did like this, now I am doing like this, correct? Read the statement. A rectangular plate 4 meter long, same thing, 4 meter long, 1 meter wide, now it is not depth, it is wide, is immersed horizontally in water in such a way that 4 meter side is parallel to the water surface, exactly like I am showing this model, and 1.5 meter below it. Find total pressure on the plate. Again the water level is somewhere at 1.5 meter, same thing, okay? Earlier it was like this, now it's like this, correct? Now that is the reason I have given a note here, same plate now horizontally immersed. No need to worry, it's again a simple problem. Gamma W, which is the specific weight of water, my dear students, you know the value is 1000 into 9.81, the value is 9810. Area of rectangular plate, A, 4 into 1, 4 meter square. The center of pressure and the centroid, they will coincide. Now in a horizontal position, centroid is also here, center of pressure also is here. Earlier it was not like that. Earlier centroid was here, center of pressure was lower. Now in horizontal position, as the depth is same everywhere same, so centroid and CP, they will coincide, okay? Yeah, theta is actually 0 now, alright? So HC is directly the value. Next comes here FW 9810 A into HC. Is it okay? Next we will take one more problem on a triangle. Now you can see here, I am reading the statement, a vertical wall theta is equal to 90 degree shaped as an inverse triangle with h is equal to 3 meter, the height is 3 meter and W is 2 meter wide, at the top is submerged in water. The wall is just level with the surface. It's a triangular thing, exactly like this, you can say. This is the water level and the width is 2 meter, the depth is 3 meter. Is it okay? Same to same thing, concept is same, Let us read the statement again. A vertical wall shaped as an inverse triangle with h equal to 3 meter high and w is 2 meter wide at the top, that is 2 meter here, is submerged in water. The wall is just level with the surface of the water upstream. Determine the force exerted by the water on the wall by using the centroid method. Okay. As far as the problem is concerned, the only change is it is a triangle instead of a rectangle. Second thing, earlier the water level was higher, it was at 1.5 meter here. Now water level is exactly same, it is in flush with the triangle wall, correct. First we will start calculate the area of the triangle. I think my students, they know how to calculate area of a triangle. A is equal to half base into height. I have shown in the formula also, half base into height, okay. And also calculate BH cube by 36, which is the moment of inertia parallel to centroid, okay, in the x direction. So come back to the slide. Now magnitude, how to calculate, the formula remains the same. Now the centroid is at a distance of h by 3. You can see in the diagram also, table also, h by 3. So what is the height of the triangle? Height of the triangle is 3 meter. So what is the h by 3? From this point only 1 meter, h by 3, correct. So we go there and show you here, c is 1 meter. So gamma w, which is 1000 into 9.81, area half base into height, with my students they know how to calculate. Half base is 2 meter, height is 3 meter, and into the hc. hc value is from there h by 3, 1 meter from the free surface, which I showed here also, and area is also shown, and Ig is also shown. What is the Ig? Is the moment of inertia parallel to this centroid, BH cube by 36. So it will become 3 cube by 36, which is around 1.5. So please calculate in your calculator and see that value is same. So as far as the force is concerned, there is no problem, which is the same formula. We use gamma hc into A. Gamma is 1000 into 9.81 into area of the triangle, half base into height. hc is height of the triangle is 3 meter, which we can see in the diagram also. H by 3 from this point, the value is 1 meter. So you can see there the value comes to be around 29.43. So the force, hydrostatic force, you are able to get. Now let us march to the next one. We would like to know where this hydrostatic force is acting, maybe in this direction, at where the location is. The formula is again same thing, center of pressure is equal to h bar or hc, Ig sin square 90 degree, theta is 90, mentioned in the question also. You can see here it is a vertical wall, into A into h. H bar is 1, as I mentioned, 3 meter, h by 3 is 1 meter. Is it okay? So 1 meter is coming in the formula. Ig 1.5 here, sin square 90, everybody knows sin 90 is 1. So we calculate 1.5 into 1 divided by the area of the triangle, half base into height into hc bar, which is nothing but 1 meter. So if you calculate hc bar, it is coming 1.5. Now you can see in this case as compared to the previous problem you remember, it is very near 2 meter and 2.042 for rectangle. Exactly, this rectangle we have done, no, this is 2 meter and HCP is 2.042, hardly 0.042 meter or 4 mm you can see. But as far as the triangle is concerned, you can see the value is fairly different. The centroid is at a distance of 1 meter, because height is 3 meter. I divide h by 3, 3 by 3 becomes 1, but you can see the center of pressure by the cursor I am showing, it is 1.5 meter. So definitely the gap is half a meter this time. So you can see the shape, how it influences the location of center of pressure. What do you mean by location of center of pressure? It is the point where this hydrostatic force Fr is going to act. It means at this location, not at the centroid. Is it okay? So with this we further march to the next question. This time we will go with another one, circular one. Let us read the statement, my dear friends. Calculate the total hydrostatic force and location of center of pressure for a circular plate of 2.5 meter diameter, 2.5 meter diameter, immersed vertically. See this, I have underlined immersed vertically. It means a circular plate is here and it is immersed vertically, okay, and the top level is at a distance of 1.5 meter. It means water level to this top is 1.5 meter, which is also shown in the diagram. Is it okay? Now let us see how this question goes. Calculate the total hydrostatic force and location of center of pressure for a circular plate of 2.5 meter diameter immersed vertically in water with its top edge 1.5 meter below the oil surface. Mind it well, this time it is a oil, not water. Number 2, it is a circular plate, right, of diameter 2.5 meter, right. Okay. Next one is very important, which is the depth of this 1.5 meter. So we will apply the same concept. The gamma of the oil will be calculated pi 9 into 1000, 900 kg per meter cube. Hc, I would like to know where the center of pressure. The value here is 1.5 plus this is 2.5 is the diameter. From here to here, I will take half of that. What is the value? 1.25. So 1.25 plus 1.5, how much will be that? 1.5 plus 2.5 by 2, 1.25 plus this to this top 1.5, this will be 2.75. So we know Hc value, we calculate the force with the help of same formula and we go ahead. Now in this case you can see here the force is gamma oil, I think I have mentioned here, 0.9 into 1000 is the density of the oil. Gamma of the oil is 900 into 9.81, which is nothing but rho oil into G, same formula. Now calculate the value of gamma oil into area into Hc. So when we calculate, we get this force. We know the gamma of the oil as 829, area pi r square into Hc, which is 2.75. So force is cleared. Now we need to calculate where the location of this. Yes, you can see here, this is the centroid, which is the center of the circle. I want to calculate center of pressure. Apply the same formula, there is no issue. Theta is now 90 degree. Hcp is equal to Hc plus Icxx into sine square 90, which becomes 1 into area into Hc. Okay, let us calculate the value of the moment of inertia. You can see I have applied this formula. Circle, pi r square is the area and moment of inertia is pi r square by 4. Okay, so pi r square by 4. You can see the diameter is 2.5, so radius will be half of that. Okay. In the slide I have calculated, I will come back to the slide. You can see r is equal to d by 2, I have mentioned there, and it is 1.25. d by 2 is 2.5 by 2. You know very well, this total is 2.5, half of this will be 1.25. What is the moment of inertia? Pi r 4 by 4. So keep the value of pi into r 1.25 raised to power 4 divided by 4. Calculate the moment of inertia of the circle. Now we calculate the center of pressure. Center of pressure, the formula is same. Hcp is equal to Hc plus Icxx divided by A into Hc. Okay, we substitute Hc as 2.75 and I as 1.9175 divided by the area into Hc, again 2.75. If you calculate, it will be 2.8925. So this is the way we have to calculate the total force and the hydrostatic center of pressure for the circular plate, which is submerged at a distance of 1.5 meter from the top. Is it okay? So in this case we have learned how to calculate the same concept. I am just varying the type. First I have taken a rectangle B by D, second I have taken a triangle which is inversed is a B by H, and when we have gone for a circular plate, again submerged at a distance of 1.5. As far as the formula is concerned, it is same. The hydrostatic force is given by gamma W into area into HC, which is the depth of the centroid from the free water surface, depth of the centroid from the free water surface, right. As far as the center of pressure is concerned, we are able to calculate based on the HC plus ICXX divided by A into HC. Is it okay? So, we will go to the next problem. Let us take a slightly different problem which we have not discussed. It is slightly a lengthy problem, but be sure that we are going to do it very slowly, right. Find the hydrostatic force, find the hydrostatic force per unit width on rectangular gate AB. Can you see the AB? AB is in the very small portion which is mentioned here, and location of center of pressure for a this situation where one side you have water and one side you have glycerine, right. Let us see this equation or this problem in this way. This is a gate AB, this is the gate AB. In this side you have water, in this side you have water, in this side to some depth glycerine, okay. This is AB, glycerine is up to this point, water is up to this point, one more wall is there in this side, okay. What I am showing is only the AB, right. Is it okay? Now we have to calculate the resultant force, we have to calculate the resultant location. Let us take one by one. Problem is clear? I will repeat again. This is a portion A to B. This side you have water up to this level, again it is rectangle and water. This side glycerine is there up to this point. The specific weight of the glycerine is given in the problem, 15,300 Newton per meter cube, and he is asking you what is the resultant force acting on this AB. So, how to solve this problem? This problem is split into two portions. Number one, the water side, left side, this side, okay, and the right side is the glycerine side. So, we will start first water side. First of all, you can see the length of the gate AB perpendicular to this one, I think this side, okay. This is A, this is B, this is your length, it is 1 meter, right. Now, water side area is 2 into 1 meter, because that is the, you can see it is 2 meter and this is 2 meter and this perpendicular is 1 meter. So, we get 2 into 1 as 1 meter, gamma W 9810, which is nothing but the specific weight of the water on which is on the left hand side, minus 12 on the water side. Now, first we would like to know what is the centroid location of this gate with reference to water side. Again repeat, location of this gate centroid with reference to water depth, how much it is, because the levels are different, one is here, one is here, right. So, we take that, we start from the top. You can see, my dear friends, I am moving the cursor one by one as the arrow is also shown. Here to here you can see 1.8, 1.8, from here to here 1.2, 1.2, and half of the gate, as I told the gate is 2 meter. So, half of that 2 by 2 which is mentioned in the formula also, you can see 1. So, 1.8 plus 1.2 is 3 plus 1, it is a 4 meter. It means from the left side the centroid of this particular gate is at a 4 meter. You want me to repeat? Repeat. Starting from the top, we are want to look at this position. We will go reverse this time. AB total length of the gate 2 meter, half of that 1 meter, okay. So, 1 meter from here to here, from here to here how much? 1 plus 1.2, 2.2, from here to here 2.2 plus 1.8, we have reached the top of the water level. So, the value is 4. Is it okay? Now, I'll apply the formula. What is the formula, my dear students? Gamma W into A into HC. So, gamma W 9810, area of the plate 2 and Hc is 4, you can calculate. So, this hydrostatic force acting from this side, right. Where is the location? Acting at what? We go back to our formula, my dear friends. You can see on the left side of the water side, where is the location? It means this side I want to locate. Formula is Hc, which is 4, Ig Bd cube by 12, 1 into 2 cube by 12, sin square 90, 1, area same value into 4, you can calculate. So, now one more thing, distance from B, I want to calculate from distance from B. This is from this top point, okay. This gate, it opens like this, so there is a hinge. So, from the point B we can calculate 5 minus so and so. Is it okay? Now, let us go to the glycerin side. In the glycerin side, we apply the same concept, area is 2, same thing this side, and now I want to calculate Hc bar. Now, you can see Hc bar is 1.2 plus 1, which is 2.2, okay. Here it is 1.2 height, half of this 2 meter, again 1, same thing, gamma W into A into Hc bar, you please calculate, you get this value. Now, let us see the center of pressure on the glycerin side. You want me to repeat? Okay. Hc is here, it is 1 meter here, and up to glycerin height, how much? 1.2. Can you see that? 1.2 here, half of this 1 meter. So, Hc value is 2.2. Substitute here 2.2, area is same 2 meter, and gamma W is given in the formula or in the statement 15,300, which is heavier than the water. So, we get this value here, and this value will be acting in this direction. So, the hydrostatic force of water is acting in this direction, and hydrostatic force in this direction is acting, glycerin is acting in this direction. They are opposite to each other. Water is acting this way, from the B point that value is given 0.917, and this side it is acting in the glycerin, this side is glycerin acting this way. So, the Hc bar, which is actually 2.352 from the top surface, again from the B point we calculate it is 1 meter. So, question arises, what is the resultant? So, very clear, whichever is more, you can see here the value of water force is more, 78,480 and this is 67,320. Subtract the 2, you can see the net force on the gate is on the water side, which is acting on this side. I have showed by a red arrow in the slide as R. Assume that it is at a distance x from the point B, R into x, and I will take moment about this point. So, water side is 78480 into 0.917, you can see here, minus 67,320 for glycerin, 67,320 for glycerin into 1 from the point B. So, if you calculate the x value, you get 0.416 meter from the point B. It means from this point the resultant force is acting in the from water direction with a magnitude of 11,160 newtons at a distance of 0.416 meter. Is it okay? So, this question gives you an idea how to calculate for a system where we have two different liquids on different side. One side you have water, one side you have glycerin. Water was more, so it was carrying more resultant force, and we have calculated the moment about a common point B for both the case, and then we got the answer as 0.416, where the location of the center of pressure is there. It means if I want to lift this gate under the submerged condition of water as well as glycerin, I need to apply a force of 11,160 force in the right side at a location of 0.416 meter from the point B. So, my dear friends, all these problems which we are discussing here are giving you an idea for a submerged plates, submerged planes, how much force is acting, where is the location, and where we need to apply to lift the gate. Is it okay? Let us take one more problem. A rectangular plate, I think this we have finished already. This is the same thing. Okay. Now let us take one more question very different way. A rectangular plate 1 meter by 3 meter is immersed in water in such that its upper and lower edge is at a depth of 1.5 meter and 3 meter. It means a rectangular plate is immersed in such a way like this only. Upper plate is at a distance of 1.5 meter. This is the water level. You can say this is 1.5 meter, and this is another water level which is at 3 meter. Repeat again. You can see this is the water level. Okay, and exactly if you want I can show here also like this. Okay, and this value is 1.5. This is the upper edge, and the lower edge is here. This is 3 meter. This is 1.5 meter. Is it okay? I am able to tell you 1.5 is here to here from in there, and 3 meter here. Determine the total pressure acting on the plate and locate it. In this case, the area of the plate, no doubt 1 by 3 meter is given. The hint to calculate the centroid or HC is simply take average of these two value, 3 plus 1.5 by 2. So what is your HC? 1.5 plus 3 by 2, which is 4.5 by 2, which is 2.25. So gamma W is, it's a water 9810. We know the total pressure force is given by gamma W into A into HC bar. It is very simple, as we followed in the vertically immersed, we also follow in the inclined plate also. So the value is 9810 into the area, which is 3 into 2.25, we get 66,217.5 Newton force. So this is the hydrostatic force. Now same thing, I think what we are seeing is exactly like this. This is a, you can see it is a 3 meter, this is 1 meter, right? This is at a distance of 1.5, this is at a distance of 3 meter, and we would like to know where it acts. No doubt the centroid will be there, center of pressure will be slightly low. We will calculate. First we will calculate the inclination. You can see the drop is how much? It is 3 minus 1.5. Can you calculate? Drop is 1.5. I repeat, the drop is 3 minus 1.5. What is this height? This is actually 1.5. Is it okay? Then what is the hypotenuse? It is the length of the plate. It means this way, this is 1.5, this is 3 meter. Difference is 3 minus 1.5. From here to here it is 1.5, and this total length is 3 meter, because I told no, plate is 3 meter by 1 meter. Is it okay? You want me to show again? You can see rectangular plate 1 meter by 3 meter, exactly like this. Okay, so 3 meter is here, 1 meter is here. So the difference is 1.5. We see the angle of inclination now. So this value is 1.5. This is 3 meter. We know sin theta definition. It is the height divided by hypotenuse. So 1.5 by 3, the theta comes as 0.5. Okay, theta is going to be 30 degree. Sin theta is 0.5. So theta is 30 degree. So we know the angle of inclination with this, say this one, this angle is 30 degree. This angle is 30. Okay. Now let us calculate the value. How we calculate? The formula is same. HC 2.25, BD cube by 12, 1 into 3 cube by 12. Depth is going to be cut here exactly. Okay, like this. No, it is going to be like this. So this is the depth. Depth side is always going to be cut. So BD cube by 12. Cut side is cubed, right? Depth side. It is depth. 3 meter is depth. Formula is, you can see, B by D, depth side, B into D cube. So in this case D is here, D is here. So this is 3 meter in the D portion. This is your 3 portion in the 3 meter. So don't get confused whether it is a 3 into 1 cube or 1 into 3 cube. No confusion. This is 3 meter. If you tilt this, theta is equal to 90 degree, this becomes depth. So depth will be cubed always. Is it clear? Shall I repeat? See, this is the depth portion. If you take it vertical, it becomes depth. The value is 3 meter. So formula is B depth cube by 12. So my dear students, it is B into 3 cube by 12. The I value is known, HC value is known. Substitute the values here. Sin square 30 degree, we got this value based on this drop. 3 minus 1.5, 3 minus 1.5 is 1.5 divided by hypotenuse, which is 3 meter, which is this 3 meter. So, we get sin theta equal to 0.5 and theta is 30 degree. So, we get center of pressure as 2.333. Now, in this case you can see the rectangular case only, the centroid was at 2.25, but center of pressure is only 8 centimeter away. I repeat, centroid was 2.25 from the free surface, and this is at a 8 centimeter away. So, this also gives an idea how to calculate the forces on rectangular vertically immersed, then triangular also we have done, then we have done circular also. So, that has given you an idea. We have taken the 3 problems today. One, we have gone with the rectangle, how the centroid is here, center of pressure here. We have taken next problem on the triangle, same thing, centroid was here and hydrostatic force was acting at center of pressure, which was slightly more. You remember the answer was 1 and 1.5, and circular case we have also done same thing, centroid was here and center of pressure was here. So, we are able to do one more problem on an inclined plate, which is earlier we have shown the centroid was at 2.25, which is in the cursor, and the center of pressure is slightly below 2.333. So, with this I think I will wind up. We will see you with more problems on the next section. Thank you very much. Thank you one and all.